All right. So today we are going to look at some more properties of cyclic codes. So okay. So suppose C is a cyclic code and I say that its parameters are n comma k with generator polynomial gx. We know that gx will divide x raised to power n minus 1, right? So any divisor of x raised to power n minus 1 will generate a cyclic code. Now that means we can write down x raised to power n minus 1 as gx into some polynomial hx. We know that the degree of gx is n minus k and degree of hx is k. Both are monic polynomial. Okay, that means the leading coefficient is 1. Okay, now if you look at a code generated by hx, call it c prime, some code c prime. Note that c prime may not be equal to dual of the code, dual of the c, so this is not equal to gx perp. Okay, so then how do we find the dual code? Well, it turns out that there is a relative polynomial which we can look at it, known as reciprocal polynomial from hx, and that gives us dual code. So in order to find out this how it works, let me start with a result. It's a very important fundamental result here. Okay, so suppose C is a cyclic code generated by gx. So it is a ring Rn. Rn is, I can call it, say, fqx mod x raised to power n minus 1. Okay, and hx is our check polynomial. So suppose check polynomial is hx. This implies that gx into hx is equal to x raised to power n minus 1. Okay, then we can say that if we take ax to be any code word of Rn, okay, so ax is any vector or any polynomial. So if ax is in the ring Rn, then ax is a code word of C if and only if cx into hx is 0. Beautiful result. So what it says that if you take a polynomial Rn, then that will be a code word if and only if cx into hx is equal to 0. Cx into the check polynomial hx is 0. Okay, so we can prove in the two ways because it's if and only if. So what we can do here, so first we assume that ax is a code word. Okay, now we know that gx into hx is equal to x raised to power n minus 1, right, which is 0, mod x raised to power n minus 1, right? So that means if we take a arbitrary polynomial cx in C, okay, so this implies that cx can be written as some ax into gx, right, for some ax in Rn. Okay, now if you multiply both sides by hx, we will get cx into hx is equal to ax into gx into hx. Now this quantity is 0. Okay, so we get that cx into hx is equal to 0 modulo x raised to power n minus 1. So this portion is straightforward. Okay, if something is a code word, then we know that sorry, so here actually I forgot, this is not A, this is C. Okay, fine. If cx is in Rn, is a code word of C, if and only this is the case, right? Now on the other side, so if you want to prove the other side, this was from this side. If cx into hx is equal to 0, suppose it is given that the cx into hx is equal to 0, I need to show that cx is a code word. Okay, so by divisional algorithm, what we can write that cx can be written as some quotient polynomial qx into gx plus rx, where degree of remainder polynomial rx will not exceed degree of gx, which is n minus k. Now cx into hx is 0. This implies that we will have rx into hx is equal to 0, right? Because when we multiply both sides by hx, cx into hx is 0, qx into gx into hx will be 0, so we are left with rx into hx is equal to 0, right? And this is true mod x raised to power n minus 1. Okay, now but the degree of, we know that the degree of rx into hx will be less than n minus k plus k is n, right? Therefore rx into hx is 0 in fqx as well. This implies that since hx is non-zero, rx is equal to 0, and this implies that cx can be written as qx into gx. Okay, that means this belongs to this C. Okay, so this is our result, that cx is if you take a polynomial cx in Rn, it is a code word of C if and only if, okay, cx into hx is equal to 0. Now so note that a note I would like to say, dimension of code generated by hx is n minus k. Is n minus k, okay, which is same thing as dimension of C per. So many times people are confused that if we take a generator polynomial as hx, we will get the code C per, but that is not true. But as I mentioned, code generated by hx may not be equal to actual dual code of C. Okay. So then what is the result? So I'm going to mention the main result now here. If C is a cyclic code generated by GX, C is our NK cyclic code, I can assume. And suppose check polynomial is Hx. Okay. We know that Gx is of degree n minus k and it's a monic polynomial. Similarly, Hx is of degree k and it's monic polynomial. So suppose Hx is of the form h0 plus h1x plus dot 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 hk x is for k. Okay. Then we claim that the parity check matrix, then the parity check matrix of C is the matrix H, which is hk, hk minus 1, h0, 0, 0, hk, h0, 0, and so on, 0, 0. Somewhere down the line it will be hk, hk minus 1, h0. So all cyclic shift of the first row. And so this is our first thing, that the parity check matrix will be this. Second property, that C perf is nothing but a code generated by R. What is H star x is known as reciprocal polynomial. H star x can be written as hk plus hk minus 1x plus dot 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 h naught x raised to power k. So from hx we can get the reciprocal polynomial this. Okay, so how do we prove this result? Proof is really straightforward using the lemma that we just proved, that Cx in Rn is a code word of C if and only if Cx into Hx equal to 0, right? We are going to use this result now. So the proof goes like this. Suppose Cx is a code word like C0 plus C1x plus Cn minus 1 x raised to power n minus 1 is a code word in C, right? Now if this is a code word in C, this implies that Cx into Hx is equal to 0, right? Now Hx is of degree k, right? So in this product, since Hx is of degree k, coefficient of x raised to power k, comma x raised to power k plus 1, dot 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 x raised to power n minus 1 must be 0, right? Because the degree of Hx is k only. So all the rest higher order terms will be 0, the coefficient of those terms. So what are these coefficients? I can write it down. The coefficients are C0hk plus C1hk minus 1 plus dot 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 ck h0 is equal to 0. We have C1hk plus hk minus 1 plus dot 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 ck plus 1 h0 is equal to 0, and so on. Cn minus k minus plus dot 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 Cn minus 1 h0. Okay, so that means these coefficients must be 0. I have written the coefficient and their value is 0. Now this shows that any code word C0 C1 minus 1 of C is perpendicular to the vector hk hk minus 1 h0 and 0 to this and its cyclic shift. And its cyclic shift. Okay, so that means any code word C0 C1 Cn minus 1 of C is perpendicular to the vector hk minus 1 h0 dot 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 0 and it is cyclic shift, right? Rows of h are all code words of C, right? Rows of h, therefore rows of h are code words because they are perpendicular, right, of h of C perf. Okay, now hx is a maulic polynomial, therefore hk will be 1, the leading coefficient will be 1. In that case, if you look at the parity check matrix here, hk will be 1 means there is a 1 everywhere. So there is, in the diagonal there is 1. That means all these rows are linearly independent. Okay, so this implies that rows of h are linearly independent. Now rows are linearly independent and total number of rows are n minus k. So the dimension of C perf, right? So H is the generator matrix of C perf. Okay, so this is a very fundamental result that shows that parity matrix is given by this. If C is a cyclic code, NK cyclic code with check polynomial Hx, Hx is a polynomial like this, H0 plus H1x plus dot 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 Hkx raised to power k, then the parity check matrix of C is given by this. Now the second thing, we can look at it, what is the reciprocal polynomial? Okay, so that is another interesting thing. If you look at the reciprocal polynomial, so our claim is that h star x, our reciprocal polynomial, how do we define it actually? It is nothing but x raised to power k times h of x inverse. We want to show that this divides x raised to power n minus 1. Okay, so now if you look at hx, we know that hx into gx is equal to minus 1, right? This implies that if you replace x by x inverse, we will get hx inverse gx inverse is equal to x minus 1 raised to power n minus 1, right? Multiply whole thing by x raised to power k, so we are going to get x raised to power k hx inverse, and then I can here adjust the term by multiplying it by x raised to power n minus multiplied. We this for n on both sides, right? So it's gx inverse the same thing as x raised to power n, x raised to power minus n minus 1, which is 1 minus x raised to power n. And this modulo x raised to power n minus 1 is 0 actually, right? So this implies that this quantity here is h star x, reciprocal polynomial. This implies that we can say that h star x divides x raised to power n minus 1, right? So the code generated by H star X is actually CPerf. It's a cyclic code with generator matrix H. Okay. So that's the proof of that completes the proof of the theorem. I'll just take a small example here now. If C is our 7-4 code with generator polynomial gx equal to 1 plus x square plus x cube, then check polynomial hx will be x raised to 7 minus 1 divided by gx, and it turns out that it is 1 plus x square plus x cube plus x raised to 4. So from this I can find out what is h star x. The reciprocal polynomial is x inverse x raised to power k times h of x minus 1. So we arrive at 1 plus x square plus x raised to power 4. So h will be 1 1 1 1 1 1 1 0 1 0 0 0 0 1 0 and 0 0 1 1 1 0 1 is the parity check matrix of C. Okay. Another example, I mean, that will be very famous. We know that, I mean, of course, I will show you how this can be done. That x3 minus 1 can be factored as x minus 1, x raised to power plus x raised to power 10 plus x raised to power 6 plus x raised to power 5 plus x raised to power 4 plus x square plus 1 times x raised to power 11 plus x raised to power 9 plus x raised to power 7 plus x raised to power 6 plus x raised to power 5 plus x plus 1. So which is nothing but I can call it as x minus 1 into g1x into z2x. The first polynomial I can call it g1x and second g2x. If we take a code c1 generated by g1x, it turns out that this is nothing but 2312 binary Gole code, which is a cyclic code. Beautiful. And if we take c2 as generated by g2x, it turns out that c2 is equivalent to c1. Okay. And g1x and g2x are reciprocals of each other. And I think the reason is clear because the Gole code is a self-dual code. Okay. So this important result. I think finally today I think I am going to finish the cycle. I'll just mention the final result about the syndrome. Okay, so if H is a parity check matrix I n minus k and something like this, parity check matrix of a query code, okay, query cyclic code C generated by gx, then syndrome of vector w which belongs to fqn is nothing but wx reduce it to modulo gx. This is an important result, and we are going to I'm not giving the proof of it, but we are going to actually show in an example later on how we can decode. Okay, so I think that's if you want, we can take an example again. Actually, our code is 743 Hamming code. Okay, generator polynomial gx is 1 plus x square plus x cube, and h is I3 slash a, where a is 1110 0111 1101. If w is 0110 so wx will be x plus x square 4 plus x raised to power 5 modulo gx. If you want to find out what is the value, it turns out that I can write it down as x plus x square times gx. So this value is x modulo gx. Okay, so this is our syndrome. So this is our syndrome. Okay, so we can compute the syndrome directly by computing the reduction of wx modulo gx. Okay, so finally I would like to show you some nice standards that are currently used. And here is that picture here. You can see that some of these standards are cyclic redundancy code CRC, CRC4, CRC7, CRC8. So CRC4 generator polynomial is like this, CRC7. So if you look at the industry standards and many applications, you will see that these polynomial pretty standard. They are used in cyclic redundancy check. They are called as cyclic redundancy check, CRC. CRC7, CRC8, CRC12 is a degree 12 polynomial. Okay, CRC-NC, CRC-24. Okay, so these are the standards, which are used. Many times, if you have downloaded, some file, big file, so they do have CRC checks. So they say that you verify that CRC check is correct. So these are standards. Anyway, so I think that's all for the cyclic code today. In the next class, we are going to start a new chapter. Especially, we will be focusing more on the finite field. Okay. Thank you.